slide outlines the partial factor of safety of the actions at the ultimate limit state and serviceability limit state. The ultimate limit state is referring to the critical state of the structure where beyond which the structures become unstable and endure significant damage and collapse. As for the serviceability limit state, it is often refers to the well-being, good conditions, and durability of the structures. As long as the serviceability limit state is not exceeded, the structure will remain in good conditions and will be long-lasting throughout its service life. You can see here the partial factor of safety for different states will have different numbers. For the serviceability limit state, the partial factor of safety is equals to 1.0 for the permanent actions and variable actions. As for the ultimate limit states, the partial factor of safety may not necessarily be 1.0. Under certain conditions, it can be equals to 0. From the table here, you will see a few terminologies: the permanent action, the leading variable or variable actions, and accompanying variable actions. The permanent actions is normally referring to the actions which is more or less constant throughout the service life of the structures. It is always associated with the self-weight of the structures and the materials or the finishes of the structures. As for the variable actions, it is normally refers to the temporary imposed loading which is arising from the traffic of people, wind, snow loading, and other of the like. There are leading variable actions and accompanying variable actions. The leading variable actions is referring to the predominant variable actions of the structure, such as a imposed crown load, and the accompanying variable actions is the secondary variable actions, such as the effect of the wing loading. From the table here, there are another two terms, unfavorable and favorable conditions. They normally refers to the effect of the actions on the design situations, whether to increase or decrease the loading acting on the structures. When the actions intends to decrease the loading acting on the structures, we call that loading as a favorable actions, while it increase the loading actions acting on the structures, it become unfavorable. The factor of safety for the favorable and unfavorable conditions differs. To simulate the most critical situations, we would increase the tolerance for the unfavorable actions while decrease the factors for the favorable conditions. This is so that the structures is undergoing the worst case scenario during the analysis. There are three sets of the conditions to be considered. The first one is for checking the static equilibrium of a building structures. This is normally referring to the stability and overturning resistance of the structures. The second one is for the design of the structural element. It excludes the geotechnical actions. These conditions is used mainly for the structural design. The third condition is an alternative to the first and second conditions. The factor of safety of the different conditions differ slightly. In general, for the stability check, the factor of safety it will be slightly smaller for the permanent actions. As for the structural design check, the factor of safety will be relatively large for the permanent action. The permanent actions is normally easier to predict in comparison to the variable action. It is basically computed from the weight of the material. For that, the factor of safeties are normally smaller than the variable action. And due to the flowability nature of the variable actions, it can be there, it can be not there. For the variable actions, which is favorable, the effect needs to be ignored. Therefore, the factor of safety will be equals to 0. It is also noticed that the partial factor of safety of the leading variable and the accompanying variable, it will be totally same. The difference will be the variable actions and the permanent actions. Nevertheless, determining the leading variable actions and the accompanying variable action is still important. As in the later stage of the analysis, there will be another factor differentiating the leading variables and the accompanying variable actions, which is not seen here. For the time being, you can simply comprehend that there is one set of the partial factor of safety for the permanent actions and another set of partial factor of safety for the variable actions.